All right, so we just did problem 4, and now we're going to move on to problem 3, which is, like I said, the same type of problem as problem 5. Again, these numbers are just assigned to the order of the pictures you sent me. So, problem 3 says the equilibrium constant Kp for the following reaction is 2.74 at 1150 degrees Kelvin. Calculate Kc for this reaction at this temperature, and then it gives us this chemical equation. All right, so these questions are actually pretty easy. All you really need to know is the formula. All right, so I'm just going to give you the formula right now. And that formula is Kc is equal to Kp times R times T to the power of, I'm sorry, let me check this real quick. To the power of negative change in N. All right, there we go. All right, so that's the equation we're going to use, this one right here. There's another equation in case they're ever asking you for Kp instead of Kc. It's the exact same. All right, Kp is equal to Kc times RT, except this time, instead of to the power of negative change in N, it's just to the power of the change in N. There's no negative sign. But we don't need to worry about this one right now because the two questions you sent me are only asking for Kc. So this is the equation we're going to use. Now let's look at this equation. What do all these letters mean? Right? There's a lot of stuff. So to start with, R is always 0.0821. All right, that's just like a law, right? That's just a number, and it just means this number. So anytime you see R is always 0.0821. So that's what you're going to plug in here. All right, T is just the temperature in Kelvin. All right, T is just the temperature in Kelvin. Now, the change in N, this one's a little tricky. The change in N is the sum of the coefficients of the products minus the sum of the coefficients of the reactants. And when I say products and reactants, I mean only gaseous products and reactants, all right? So actually, I'm going to write that out just so you can get a better idea of what I'm saying. So the change in N is the sum of the coefficients of gaseous products minus the sum of the coefficients of gaseous reactants. All right? Now that may be a little confusing, but I'm about to explain it. All right? So that's what the change in N is. So for example, in our problem, the equation it gives us is 2SO3 gaseous, and then our little equilibrium sign, 2SO2 gaseous plus O2 gaseous. All right, so if we look at N, it says the sum of the coefficients of gaseous products minus the sum of the coefficients of gaseous reactants. All right, so let's first look at the sum of the coefficients of gaseous products. So we're going to look at our products. We're going to say which ones are gaseous. Well, it's both of them, right? Because there's a little g. If there's not a little g, we're not going to worry about it. All right? So if this was a g and this was an s instead of a g right here, we wouldn't worry about this s. All right? But since these are both g, we're going to add them both together. All right? So there's a 2 here and there's a 1 here. We just don't write it, right? So on this side, the sum is 3. Right, we got a 2, we got a 1. Now remember, this is only the case if they're both gaseous. If this one was a solid instead of a gas, this would just be 2, right? Because it's 2 plus, well, we don't worry about this one because it's S. But in this case, since it is G, it's going to be 3. All right, so it's 3 for the sum of the coefficients of gaseous products. Then we subtract from this 3 the sum of the coefficients of gaseous reactants. Well, if we look at our reactants, we say which ones are gaseous. Well, this one is gaseous. And since there's only 1, we don't need to add it to anything else. So it's just 2. So it's 3 minus 2, which is 1. All right, so that means our change in N is 1. All right, now all you need to do It's just plug and chug. Give exactly what it gave you in the equation and then solve it out. All right? So Kc is equal to, let's read the question. The equilibrium constant Kp for the following reaction is 2.74. So it gave us Kp, which is what we need right here. It says it's 2.74. All right? The equation, the constant Kp is 2.74 at 1,150 degrees Kelvin. All right, so it gave us the temperature too, which is another thing we need. And then remember, we already know R, because R is always 0.0821. So we have 2.74 times 0.0821 times the temperature in Kelvin, which is 1150. All right, and then to the power of negative change in N. All right, now we found the change in N to be 1. So that means this is to the power of -1. All right, so that's it. This is our equation right here. And then you just plug this into your calculator exactly how it is, and it'll give you Kc as your answer. And that's it. That's all you need to do. Just plug and chug. Remember, whenever you're solving for Kc, don't forget this negative. All right. I hope these videos help, and good luck with the rest of the homework.